Hi, I'm Pablo Pintabona. Just so you know, I'm not a mathematician, just a math enthusiast with an undergraduate degree in economics. Everything you'll see here, work, tools, statement, conclusions, is mine unless I say otherwise. Even though Spanish is my first language, I'm sharing this in English to reach more folks. If you're a Spanish-speaking person, you can make use of YouTube's closed caption tool to follow along. Recall our discussion from the previous sets of videos. We are delving into Fermat's methods and directly addressing his topics. However, in this second series of videos, we are not merely stopping at where Fermat left off. Rather, we are taking a step further. We aim to expand upon his groundwork and explore new avenues, which he himself actually began to investigate. Similar to the previous sets of videos, we are committed to making these concepts accessible to beginners. No convoluted mathematical jargon that makes your head spin. Instead, we'll break it down into easily digestible portions. While it's undeniably true that subtler techniques are indispensable for unlocking profound insights into numbers, they often overshadow the joy of employing simpler tools. Let's take a moment to appreciate the basics and illustrate how they too can lead to remarkable results in problem solving. Okay, so this presentation is structured into 4 sections. Primarily, it delves into 2 extensive sections addressing the representation of primes as x squared plus n times y squared. Additionally, it includes 2 appendices that illustrate supplementary material related to the topic. In section 10, we will explore the application of the simple descent method, previously discussed, to primes of the form 4k plus 3, utilizing the representation x squared plus n times y squared. This will involve employing Nevin's congruence and subsequently analyzing the disparity between the applicability of divisibility and representation. Specifically, we will examine the Dirichlet version of composition and introduce a couple of handy formulas for further elucidation. In section 11, we will extend the application of the simple descent method to primes of the form 4k plus 1. Initially, we will broaden the scope of Nevin's congruence to accommodate primes of the form 8k plus 5. Later, we will employ an infinite descent method tailored for primes of the form 8k plus 1. Finally, we'll analyze Tonelli's shank algorithm and its mathematical building blocks, and derive from them a Tonelli's shank formula. In Appendix 1, we will initially demonstrate the application of Gauss cyclotomic formulas to the representation of primes. Following this, we will present a derivation of Gauss cyclotomic formulas utilizing elementary tools, deviating from the conventional approach reliant on complex multiplication. In Appendix 2, we will delve into how Gauss cyclotomic formulas offer multiple representations in the form x squared minus p times y squared for primes, where p is a prime for k plus 1. We will illustrate how the coefficients of the polynomials associated with each square incorporate Lucas and Fibonacci numbers, thereby unveiling elegant symmetries within the representations.